right, class. I'm getting ready to start a recording for section 8.5 for your Math 410 workbook. And that starts on page 48. And remember, for this course, I want you to do 15 minutes of learn. And then when you work on your practice, that should take at least 30 minutes. And that, doing that for each lesson does count as 5% of your in-course grade, okay? And you want to accumulate your time in learn and practice. And so I'm going to go in the learn. When you go through, you're going to go through these examples and they'll have some videos. But I just want to emphasize the steps, which we did in the correct for I think it was the 1.7 correct. So we're emphasizing these steps. And so this will be the second time you're seeing this lesson worked out. Okay, so rules for order of operations. They say simplify within grouping symbols, and examples of grouping symbols are parentheses, okay, brackets, braces, and then it says working from the innermost grouping to outward, from the innermost grouping outward. Okay. So that's if you have like embedded grouping symbols inside grouping symbols. You work from your innermost and then you work your way out. Okay. Step 2 would be to find any powers indicated by exponents. But this is also where I add to that. I also extend it so that where you can also handle or evaluate any perfect roots. And also where you can handle any absolute values. Let me just say, evaluate any perfect roots and absolute values. Okay. All right, and then number 3, it's moving from left to right. Perform any multiplications or any divisions in the order they appear. And then step 4, moving from left to right, perform any additions or any subtractions in the order they appear. So that's moving from left to right, okay? And again, order of operations, this is also called PEMDAS. So please excuse my dear Aunt Sally. So I'm going to stack the MD and the AS that way, okay? All right. All right, so we'll start with page 49 in your workbook. And we'll start with the exercises below the practice is what we'll start with. Okay, so this is page 49. Okay, so if we look at number 5, we'll start with 5A, and let me see if I can cover up the other problems for now. So we can concentrate just on 5A. All right, so what I'd like you to do is pause the video recording, and then take a minute to work 5A and take a minute to work 5B. and you should get different answers. You should get different answers. The problems look very similar as far as 24, 4, and 6. However, on purpose, deliberately, we change the division and multiplication symbol. But you should see like 99% of the time, when you work these, when you work these and you follow the order of operations, you want to get these right. Okay. And so sometimes if you do them wrong out of order, majority of time, 9% of the time, it will come out wrong. Very small chance that you work it out of order and it's still correct. Okay. So I wanted you to work both of these problems, and you should be getting, different answers for these. Okay, so go ahead and pause the video, and then when you come back, then I'll show you how to work them. All right, class, so I'm assuming that you worked them, you paused the video, worked them, and came back in. So for 5A, did you get 36? For 5B, did you get 16? Okay, so if you got those answers, that's very good. Those are correct. If you didn't get those answers, let me work them for you. So again, so you have, please excuse my dear Aunt Sally. So for problem number 1, you don't have any operations inside grouping symbols. We don't have any exponents, no perfect roots, no absolute values, but we do have M and D. We have a couple of these operations. You have the division here and the multiplication. So you have a couple of them. So you should work them from left to right. So you should do this 24 divided by 6. You should actually start by doing that first. 24 divided by 4. 24 divided by 4 is 6. Okay, let me show you that here. 24 divided by 4. Remember the top number, the first number goes inside the house. 6 times 4 is 24. 24 minus 24 is 0. Okay, that's 6. And then, so I'm going to say here, you want to do first. And then you're going to do 6 times 6. And that is how we get the 36 for that problem. Okay, let me see if I can make this larger. Okay. And number 4, look at number 4. It looks like that's related to this. A well-known mnemonic, like a memory mnemonic device for remembering the rules for operations, is SADMIP. Okay, and that's not correct. It says false. The memory mnemonic is PEMDAS. Okay, so that's related to what we're doing. Okay, now for B, again, from left to right, you want to do the multiplication first, left to right. You want to find out what 24 times 4 is. So I have a multiplication chart here, and if I use my ruler, and if I look at 24, so 24 times 1, 24 times 2, 24 times 3, 24 times 4. So 24 times 4 is 96. 24 times 4 is 96. Four times 4 is 16, carry your 1. 4 times 2 is 8, plus 1 is 9. 24 times 4 is 96. And then you're going to divide that by 6. Okay. So 96 divided by 6. Remember, the top number, the first number, goes inside the house. This is 96 divided by 6. The top number, the first number, goes inside the house. 6 goes into 9 about 1 time, because 6 times 1 is 6. You don't want to go over, because 6 times 2 would be 12. That'd be too big. 9 take away 6 is 3. So first you say how many of these 6s go into 9. Then you multiply. Then you subtract. 9 minus 6 is 3. Then you bring down the next number. Then you start your cycle of long division all over again. How many sixes go into 36? About 6. 6 times 6 is 36. 36 minus 36 is 0. So 96 divided by 6 is 16. Okay. And so you have here 96 divided by 6, 16. Okay. All right. Okay, next, go ahead and pause the video and go ahead and work number 7. And then when you come back, we'll check your answer. All right, class. So I'm assuming you did that. So when you come back and you check your answer, you should have gotten for number 7, I think you should have gotten a negative 10. Did you get a negative 10? Let me check that out. Okay, so let's see. So the first thing you want to do in your PEMDAS, please excuse my dear Aunt Sally, is it looks like you do have a P right here for the operations inside grouping symbols. And inside grouping symbols, see how you have this 2 squared? So you do grouping symbols operations inside, and you have subtraction and you have exponents. So you see the exponent would come before, see, any subtraction. So you want to actually do 2 times 2 next, which is 4. And then you're going to do 4 minus 4, and that gives you 0. So then next, when you rewrite the problem, you have 3 squared divided by negative 9 times 0 plus 5 times negative 2. And when you think about PEMDAS, right, you don't have any operations inside grouping symbols, so you get to skip P, but then you do have the E right here. You do have those right there, those exponents that you want to take care of. 3 squared is 3 times 3, which is 9. So now when you rewrite your problem, you have, this is 9 divided by negative 9 times 0 plus 5 times negative 2. Okay. And then okay, so now we think about PEMDAS, please excuse my dear Aunt Sally. So we don't have any more operations inside grouping symbols. We don't have any more exponents. But now we're down to MD, which is multiply and divide. And we do have both of them. But you see your division right here? You have both of them. And then see some times right here. And then also see your times right here. So you've got quite a few things going on here. So you got to do them from left to right. So left to right means you want to do this first. You want to do the 9 divided by negative 9 first, because you got to do it from left to right. And 9 divided by negative 9 is just a negative 1, right? So 9 divided by negative 9 is just negative 1, okay? And then you've got times 0 plus 5 times -2. So now you're going to do the times. We're going to do this from left to right. So you're going to do the times. -1 times 0 is 0. Any number times 0 is 0. Plus 5 times -2. And now you're going to do 5 times -2. 5 times -2 is -10. So now you have 0 plus -10, which is -10. Okay. So that is your answer for number 7. Okay, let's do number 8. Okay, so good. Pause the video, work number 8, and then when you come back, then we'll check your results. Okay. Okay, I'm assuming you came back and you're ready to check your result. And let's see, it looks like we should be getting a -45 for that. Okay, so we don't have any P in PEMDAS, we don't have any P, no operations inside grouping symbols. We don't have any E, no exponents, no perfect roots, no absolute values. So we probably have M and D, multiply and divide. Yeah, so we do have some multiplying going on right here from left to right. So you do have to do that first. So 14 times 3, 4 times 3 is 12. Carry the 1. 3 times 1 is 3, plus 1 is 4. So it looks like 14 times 3 is 42. And then you're going to divide that by a -2. You have -6 times 4. Okay. So multiply and divide from left to right. So take them 2 at a time. So you're going to want to do this next. And then you're going to want to do this next. Okay. So you're going to do your division in the front. And you do your multiplication in the back. Okay. And in between that subtraction sign there. So 42 divided by -2, signs are different. Different signs produce different results, negative results, and you're taking half of it. So that's kind of a big number. So if I take half on the calculator, 42 divided by -2, you're taking half of it. What's half of 42? Half of 42 is a -21. Okay. And then subtract, and then 6 times 4. 6 times 4 is 24. Okay, so you're doing 6 times 4, and you're just bringing the subtraction down. Okay, because remember we were on MD, multiply and divide. Okay, and then now we're doing just S. Now we're adding, subtracting. We're just doing our S subtracting. And remember the rule for subtracting. If you're subtracting sine numbers, I want you to rewrite it as an addition problem. So I would rewrite this. I would rewrite this as, adding the opposite. So you have -21 plus, and then the opposite 24 is -24. And now that's rule number 1. A negative plus a negative is a negative. So you add that up, 4 and 1 is 5. 2 and 2 is 4, and then it's a negative. So there's your -45. Okay, so go ahead and stop your recording or yeah, pause it or stop it, and then go ahead and do number 6. And then when you come back, we'll check your answer for that. Okay, so we're gonna come back and let's see. So 6, so actually let me see, I don't have that written down. Let me work that one real quick. I was gonna usually call out the answer. I don't have that written down here in my notes. So let me work that out. We would do multiplying and dividing from left to right because we don't have any P and we don't have any E. So you're gonna start with 15 divided by -3, and that's gonna give you a -5. Okay. And then that's going to be -5 because, 15 divided by 3, that goes into that 5 times. Okay, but it's going to be negative. Different signs produce negative results. And then you have -5 times 3 minus 10. So we're still doing the multiply and dividing from left to right. So now you're doing this. -5 times 3 is -15. And then you have minus 10. And now we're subtracting sine numbers. So they're going to want you to rewrite it as an addition problem at the opposite. So this is going to be -15 plus, and the opposite of 10 is a -10. So here we're using rule 3. Here we're using rule number 2. Oh, excuse me, rule number 1. Adding numbers with the same sign, like sign. So rule number 1 is like signs. You just add and you just keep the negative. So 10 and 15, it looks like that's going to be a -25. Okay, so then go ahead and pause the video and work number 9. And then when you come back, we'll show the answer for 9. Okay, class. And 9, we should get, I think, 129. 9, we should get 129. Did you get that? Okay, now for 9, okay, so if we have, please excuse my dear Aunt Sally. Okay, so we don't have operations inside parentheses, okay? But we do have e's. E's are for exponents, which you do have right here. And you also have right here. But also e's are for absolute values, which you also have right here. And then e's are also for perfect radicals, right? Perfect roots, right? And we don't have any perfect roots, okay? But we do have the exponents and the absolute values. So if I take care of the absolute values first, you're trying to take the absolute value of something. But what are you trying to take the absolute value of? What value? So you gotta figure what 16 minus 20 is. So this is a subtraction of sine numbers. If you have 16, you're trying to give away 20, you're in a bit of a pickle, right? Because you don't have enough. You're trying to give away 16 take away 20, right? And you don't have enough. You only have 16 and you're trying to give away 20, so you're shy 4, right? So in subtraction of sine numbers, they always want you to rewrite it as an addition problem. So this becomes, it's the absolute value of 16 plus -20. Okay. And then that now is using rule number 2, adding numbers of different signs. So you subtract 20 minus 16 is 4. And then you keep the sign of the number with the bigger distance. 20 is bigger distance from 0 as opposed to 16, and that sign beats out the positive sign. So it's a -4. But remember, you've got to take the absolute value of that. So the absolute value of -4 is just 4. Okay, then we have plus. Okay, now over here, you're doing -10 times -10, and that gives you 100. Negative times a negative is a positive, gives you a positive 100. And then you have plus. See right here we had plus. See right here we had a plus. So see, I'm just bringing those down. See, bringing those down. And now you have 5 squared. 5 squared means 5 times 5, right? 5 squared means 5 times 5. And that's 25. It does not mean 5 times 2. It does not mean 5 times 2. Not 5 times 2, which is 10. Not that, but 5 times 5, which is 25. And now you're just adding everything up. If you add all those up, looks like that's going to give you 129. Okay. Okay, now let's see. The next page. Let's look at page 53. Okay, so let's see. All right, so -2 to the 5th power. Okay, so your base is -2. Your exponent is 5. And then when you evaluate, this means -2 being multiplied repetitively over and over 5 times. 1, 2, 3, 4, 5. Okay. And if you count your negatives, 1, 2, 3, 4, 5. Yeah, you have 5. Oh, let me write it over here. 5 negative signs. 5 negative signs. 5 negative signs. So that's an odd amount. 5 negative signs is an odd amount. So an odd amount means you're going to have a little negative result. So I'll put a little negative there. And if you had an even amount, then it'd be positive, but you had an odd amount, so it's going to be negative. So I'll put the negative there. And then we'll do this 2 at a time. -2 times -2 is 4. Okay. -2 times -2 is 4. And then you bring this down. So you got 4 times 4 times -2. So that's one way you can do it. You're doing 2 at a time, pairing them 2 at a time. So that multiplication is commutative. So you could do that. And then 4 times 4 is 16 times -2. And 16 times 2 is 32, right? 16 times 1, 16 times 2 is 32. But it's going to be, you've got 16 times -2. So it's going to be -32. Different signs produce negative results. Okay, now on number 2, you've got a base of -10. You've got an exponent of 4. And this means -10 times -10 times -10 times -10. So you have 1, 2, 3, 4. You have 4 negative signs, okay, which is an even amount, which means you're going to have positive result. So you make sure you put a, you don't have to put a plus, just make sure it's understood to be positive. And this is powers of 10. There's a rule for powers of 10 is that, you know, a whole bunch of ones repetitively, 1 times 1 times 1 times 1 is 1. And you just count your end zeros. Say 1, 2, 3, 4. So you add on or tack on 1, 2, 3, 4 zeros. And it's 1, 2, 3, comma, 1, 2, 3, comma. Okay. And again, if I use the calculator to show this as a check, -2, and let me put them in parentheses the way they've got it. Here's your period parentheses. So parentheses, -2, close parentheses, raised to the 5th power. That way there's no, I'm typing exactly the way I see that. Okay, that's correct. Parentheses, -10, close parentheses. I'm raising that to the 4th power. So it gives me 10,000. Okay. All right. Then we have -6 cubed, -6 cubed. So here the base is 6 and the exponent is 3. And when you evaluate this, this means -1 times 6 times 6 times 6. Okay, so 6 to the 3rd, there's 1, 2, 3 sixes. 6 times 6 times 6. And then you got this -1. Okay, this imaginary -1. Okay, that's what that means. And so you know your answer is going to be negative because you have an odd exponent, just 1. And then 6 times 6 is 36. And then you do 36 times 6. 6 times 6 is 36, carry the 3. 6 times 3 is 18, 19, 20, 21. So it looks like it's going to be negative. Negative 216. Okay, and then number 4. Okay, this is, why don't you go and pause the video and work, take a minute to work 4, and then when you turn it back on, we'll check your answer. Okay, so I'm assuming you turned it back on. Okay, let's see. So let's see, what you should have done first was you should have done multiply and divide from left to right. So I hope you did 3 divided by -1. 3 divided by -1. And that gives you -3. Okay. All right. And then you have 2 minus -3 times 9. So next you want to multiply -3 times 9. -3 times 9 is 27, -27. Okay. And you want to be careful here because this negative is coming down from the top, right? This negative is coming down, right? Okay. But then this is also another negative. Okay. And so I would put parentheses to attention grabber, and you got double negative going on here. So now this is using rule number 3, subtraction of sine numbers. You know what they want you to do? They want you to rewrite this, right, as an addition problem. Remember what we learned in that section? So this is going to be 2 plus, and then you're going to take the opposite, the additive inverse. So you're going to take the opposite the additive inverse, and that'd be 27. And then 27 plus 2 is a 29. So you should have gotten 29 for that. Let's see. Thank you for my rules. I was going to just mention, when it comes time to take the test, our test number 1, you can either have this page out, page 15, from the co-rec, because here are the rules for sine numbers, the first 4 problems, or you can have this sheet out, the first page of page 48, order of operations, because it's more condensed. But those are also the rules there, so you can have either of those out, okay? All right. Okay, now let's see, let's keep working. I think we're on page 54 now. Okay, and I was trying to look for my answer key because I don't have 5 and 7 offhand to tell you what that is. So I was going to have you stop, pause the video and work that. But then while you're doing that, I was going to try and look for my answer key, but I might just have to work it out myself if I can't find my answer key nearby. Yeah, I can't find my 8-5. I have it around here nearby somewhere, but just not sure where my 8-5 is at. Here's my 8-7. Okay, so I'll just work them out. Let's see. I like to call it out and then, but that's fine. Okay, so here we're multiplying, dividing from left to right because we don't have any P's and we don't have any E's. So you want to do that on the left, and then you want to do the division on the right. So here, multiply, here, divide, right? So -3 times 3 is a -9. Different signs produce different results. 18 divided by -3, that gives you a -6. Okay, so 18 divided by -3, that's a -6, right? And then you bring down this minus sign, and you want to be careful because you have again that double negative action going on, and so you probably want to put parentheses. That's a attention grabber. Hey, look at me, I was a negative. 18 divided by -3 gave me a -6. And now we're going to use rule number 3, where we're subtracting sign numbers. The rule says they want you to rewrite it as an addition problem. So we're going to add the opposite. Okay, so we're going to add the opposite. Okay, so you have -9, changes subtraction right here into a plus sign, and then go and take the opposite of a -6 is a +6. And now we're going to use rule number 2. You're adding 2 numbers with different signs. You're going to have to subtract. 9 minus 6 is 3. And then you're going to keep the number with the larger absolute value. And 9 is bigger from distance from 0 than 6. So this sign beats out this sign. The negative beats out the positive. So it's going to be -3. Okay. Okay, then on 6, okay, go. I think because it has fractions, you might just want to see me work out this problem here because it's got fractions. So I'm going to work with this, work with that, okay? I'm going to divide this side, divide that side. And please excuse my dear Aunt Sally. I don't have any P's. I don't have any E's. On the MD, I had got like division, so I'm going to take care of those from left to right. But the big question is, how do we divide fractions, right? So 2 divide fractions, we multiply by reciprocal. And in case you've forgotten, reciprocal means that you flip it. Reciprocal means that you flip. And it's just the second, fraction that you flip. All right, so this is 1/8 times 10/5. Okay, and then this can be simplified. It so happened 10/5, that can be simplified. 10 divided by 5, that's just 2. So really this is 1/8 times 2. And really, 2/1 is just 2, right? 2/1 is just 2. So we usually don't write 2/1. And so remember now, when you multiply fractions, you multiply straight across. There's just an imaginary one down here. So to divide fractions, we multiply by the reciprocal. And then we're supposed to multiply straight across. And that's what I'm doing here. 1 times 2 is 2. 8 times imaginary 1 is 8. And then we're supposed to either reduce or we're supposed to simplify. Okay, if possible. It just depends what we have. So it turns out that 2/8 can be reduced. Those are even numbers. 2 and 8, those are even numbers. So even numbers in a 0, a 2, a 4, a 6, or 8. So yeah, these are even numbers. And even numbers are reduced by, for sure, by 2. I mean, maybe something else might work, maybe 4 might work, or maybe 6 might work, but for sure, you're safe with, for sure, you're always safe with 2 on the even number. So 2 divided by 2 is 1, and 8 divided by 2 is 4. 2 divided by 2 is 1. 8 divided by 2 is 4. So that took care of this right here, this fraction. But now we've got to work the other fraction right over here. So now we have 3/6 times 9/5. So 3/6 times 9/5. You flip the second fraction, and then you multiply straight across. 9 times 3 is 27. 6 times 5 is 30. And then we reduce, this can be reduced by 3. Or this is reduced by 2. This reduces by 3. 27 divided by 3, that's 9. And 30 divided by 3 is 10. And then that cannot be reduced anymore. That's lowest term. That cannot be reduced anymore. In 9 and 10. Okay, so then then we have, there was the 1/4, take away the 9/10. That's what we have. Okay. Or if you like to stack things, 1/4, take away 9/10. If you like to stack them. Okay. So now you got to find common denominators. Okay. A common denominator would be 40. A common denominator would just be you multiplying the bottom denominators, like the 4 times the 10, that gives you 40. But maybe you can find something smaller. So that's where multiples come in. And on the multiples of the denominator, the 10 is bigger, and then the 4. So LCD equals LCM equals. So you have 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30. 10 times 4 is 40. Remember that, because we said the common denominator is 40. So we shouldn't have to go past that. But we're hoping to find something smaller. Okay, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. See how that matches? Okay, then when you come over here and build up, now we're going to build up your fractions next. So we're going to build up your fractions next. So when I come to the 1/4, either I come here or I come here, depending on how you want to work, horizontally or vertically. But I'm showing building up the fraction. And then this is why we go to this. We go to this tool. If I use this method, I need to build up this fraction, and I want to find out 4 times what is 4 times what gives me a 20. So if I look at the 4, and I come over here to 4 and I count 1, 2, 3, 4, 5. I needed 5 multiples. Okay, we need 5 multiples of what? 5 multiples of 4 to get to what? To the LCM of 20. Okay, so for 4, if I count 1, 2, 3, 4, 5. So that's why these are 5s. So you either work it this way or you work it this way. Okay, same thing for the -9/10. If I go to 10, how many multiples of 10 do I need to get to 20? I needed 2. These are going to be times 2. Okay. Okay, and I can write that down. We need for 10, we need 2 multiples of, we need 2 multiples of 10 to get 20. So if I multiply this, 1 times 5 is 5, 4 times 5 is 20, take away 9 times 2 is 18, 10 times 2 is 20. Okay, same thing over here. 1 times 5 is 5, 4 times 5 is 20, take away 9 times 2 is 18, 10 times 2 is 20. Okay. All right. And so now in both cases, you have common denominators, and you're calculating 520 minus 1820. So you need to have you need to rewrite this subtraction problem as an addition problem and take the opposite of the second number. So this is going to be 5/20 plus a negative 18/20. And then that uses rule number 2. So you want to basically subtract 18 minus 5. Looks like that's going to be 13. And then you keep the sign of the number with the bigger distance, 18. Looks like it's bigger. So it looks like we're going to get negative 13 out of 20. Okay, so we're almost done with this section. I'm going to show you the 7, which is the last problem in this section, but then I'm going to do one extra one, probably in the back, because I want to show you one that's got like a fraction. I haven't seen any with a fraction, so I want to show you how to do one that's got a fraction for the order of operations. Okay, but first we'll do the P, the parentheses, operations inside parentheses. And you see that there's a subtraction sign. So you want to rewrite that as -3 plus -2. Okay. And that would give you a -5. Okay. So then when you go back and after you do, this is your P, right? Then you have exponents. So after your P, you have exponents right here. 5 squared, which is 5 times 5, which is 25. Okay. So then I have -5 plus 25 divided by -5 times 2. And so you want to multiply and divide from left to right. And so we actually have division going on right here. 25 divided by -5 is a -5. Different signs produce different results. And then bring this down. Bring that down. -5 plus a -5 is a -10 times 2. Just brought that down. Okay, so actually take that back. I should not bring this down. Let's see. So right here, I'm doing -5 times -5 times 2. -5 times 2. So -5 times 2 is -10. Bring this down. Sorry, class, bring this down. Sorry, I might have dozed off for a second. I'm sorry. Okay, and so I'm getting tired. Okay, so sorry. So that's why in class I give y'all breaks, right? In class I give y'all 8-minute breaks, and that's how come. Because if you don't, you start wondering, getting tired and sleepy. So the breaks are helpful. Okay, so -5 times 2 is -10. -5 plus -10 is -15. Because you're using rule number 1. You're just adding them up. You're just keeping the negative sign. Okay. And again, I sure wish I had my little answer key handy so that I could quickly check these. Let me just check. I know I have it. I have it here, but just I had it earlier today, so I know it's in this pile. But I need, since I was dozing off, I better make sure. Y'all can oh, there's just one last problem to show y'all. Okay, there's just one last problem to show y'all. And I'm gonna do that. I was just hoping that I could find it. Where it's at. Okay, but hopefully Hopefully that looks good though. Hopefully that looks like it's correct. If not, you can send me an email. Hmm. It looks okay. Okay. All right, let's go. One last one I'm going to show you. I'm going to just show this to you on page 52. So you have some blank papers on page 52. One problem that I haven't seen in your ebook and in your the ones the math department made was something with a fraction. I'm going to make an example that involves a fraction, and I'm gonna be using 5B, and I'm gonna be using 5A from page 49. Okay, I'm gonna make a fraction, a problem that involves a fraction that uses those. So now let me get that paper out. I know I have that to in your notes for 5B and 5A. Let me show you. Okay, here we go. Okay, here's page 49 and 5B. Right here, 5B was this. 24 times 4 divided by 6. 24 times 4 divided by 6. And then I may use a 5A. 5A is 24 divided by 4 times 6. 24 divided by 4 times 6. Okay, so for these problems, what you have to do is you have to apply PEMDAS. Please excuse my dear Aunt Sally on the numerator. And then you're going to get a little answer. And then you're going to apply PEMDAS on the denominator. And then you get a little answer and put it down. And the last thing you want to do is either reduce or simplify if needed. Not everything can be reduced, not everything can be simplified, but if you can, that would be the last thing you want to do. Okay, so you can pause the video if you're still writing. Go ahead and pause the video and then write that down, and then come back. And what I'm going to do now is I'm going to work this out. So I'm going to save time because we already worked out 5A and 5B from page 49. So this 24 times 4 divided by 6, that was 5B. And then this one was 5A from that page. So the answer that we got for 5B was 16. And the answer that we got for 5A was 36. So I'm just doing that to save class time. Okay. But if you had a fraction, if you had a problem like this, a PEMDAS problem like this, and it had a fraction, you would have to apply PEMDAS on the numerator, get a result. Then you have to apply PEMDAS on the denominator, get a result. So you would have some scratch work down here. You don't have enough room here. So you would rewrite the numerator here, rewrite the denominator here, and do your scratch work, and then come back up and put your answers there. And then, so what you don't want to do is, remember, you don't just want to go straight to the calculator, just type that in. What you don't want to do is you don't want to just do this. 24 times 4 divided by 6. What you don't want to do is just type that in and that's the right answer and get that. But you have to show your work. You have to show me some steps. Usually usually problems take at least 2 to 3 steps, If you show more, that's fine. But you see, usually you have steps you have to show. Yeah, even this one had a few steps. You cannot just have poof the answer and no steps. We're expecting steps. So you want your full credit, you've got to show your steps, because I want you to avoid just typing that in. We're not interested if you're a good typist. We want your thought process, your critical thinking process on your steps. So you see, even this one had a couple of steps. See, so you got to show your steps. Okay. But then once you show your work here, you show your work here, you get that, then you got to reduce it. And so it looks like this can be reduced repetitively over and over by 2, because these are even numbers. But also, I think if you go larger, something larger than 2, like 4, I think that would work too. Let's see, faster. 16 divided by 4 is 4. See, as long as you're not getting any decimals, and you just try it. You may not be sure, but that's why you double check. 36 divided by 4. As long as you're not getting any decimals, then we're fine. If you get a decimal, then yeah, you stop and then you try go back down to 2. But we're not getting decimals, and that does look like its lowest terms, and that's a proper fraction. Okay, and you don't make proper fractions into mixed numbers. Okay. All right, so that's the lesson. Okay, hope that helps. Okay, good luck with your homework. Take care.